Imagine staring into the vastness of space, billions of stars twinkling like tiny fireflies against an endless black canvas. But then, in the middle of this cosmic dance, there are dark, invisible monsters, objects so powerful, so mysterious, that not even light can escape them. Black holes, they warp time, bend reality, and swallow entire stars without a trace. But what if I told you that black holes are just the beginning? That the universe is filled with bizarre, unexplainable anomalies, things that defy the very laws of physics? What if time itself could be torn apart? What if there were regions of space where reality glitches, and no one knows why? Today we're diving deep into the most mind-bending mysteries of the cosmos, black holes, cosmic anomalies, and the strange forces lurking at the edge of our understanding. Get ready, because space is about to get a lot weirder than you ever imagined. The nature of black holes, cosmic beasts of destruction. So what exactly is a black hole? A black hole is a region in space where gravity is so intense that nothing, not even light, can escape. But how do they form? The most common way is through the death of massive stars. When a star many times larger than our sun runs out of fuel, it collapses under its own gravity, triggering a supernova explosion. If the core left behind is dense enough, it keeps collapsing until it becomes a singularity, a point of infinite density. Surrounding this singularity is the event horizon, the point of no return. But here's where things get really strange. According to Einstein's general relativity, time slows down near a black hole due to its intense gravitational pull. If you were to watch an astronaut fall into one, they would appear to freeze in time as they reach the event horizon. From their perspective, though, they'd fall in normally, until they reach the singularity, where physics itself breaks. Down and then there's Hawking radiation, a mind-blowing theory proposed by physicist Stephen Hawking. He suggested that black holes aren't completely inescapable. They actually emit radiation, and over trillions of years, they can evaporate and vanish. But if black holes can disappear, what happens to everything they swallowed? Does information truly vanish forever? This is known as the black hole information paradox, one of the biggest unsolved mysteries in physics. But black holes aren't just cosmic vacuum cleaners. Some of them are colossal, sitting at the heart of galaxies. The supermassive black hole, at the center of our Milky Way, Sagittarius A, is over 4 million times the mass of our Sun. But even bigger monsters exist, like TON 618, one of the largest black holes ever discovered, estimated to be 40 billion times the mass of the Sun. Yet for all we know about black holes, there are still anomalies, strange, unexplained cosmic oddities that defy everything we thought we understood about the universe. Cosmic anomalies, the universe's greatest mysteries. The cosmos isn't just home to black holes. It's filled with bizarre and unexplainable events that continue to puzzle scientists. Let's start with the Great Attractor, a mysterious force pulling entire galaxies toward it at millions of kilometers per hour. Scientists believe it's some kind of massive gravitational anomaly. But here's the catch. We can't see it. It's hidden behind the Milky Way's thick dust clouds, making it one of the biggest cosmic puzzles out there. Then there's the Bootes Void, an eerie, almost empty region of space, 330 million light-years across, containing almost no galaxies. It's as if something erased everything inside it. Some theories suggest it could be a remnant of an ancient cosmic collision, while others entertain the idea that something far stranger is at play. Perhaps even the presence of an advanced alien civilization. And speaking of strange, let's talk about fast radio bursts, FRBs, intense, millisecond-long bursts of energy that come from deep space. These signals are so powerful they can travel across billions of light-years. But where do they come from? Some scientists believe they could be neutron stars colliding, while others suggest they might be the result of alien technology. In 2019, astronomers discovered an FRB that repeats every 16 days, a pattern unlike anything we've ever seen. Then there's dark matter and dark energy, two of the biggest unsolved mysteries in cosmology. We know they exist, but we don't know what they are. Dark matter makes up most of the universe's mass, yet it's completely invisible. It doesn't emit, absorb, or reflect light. It only interacts through gravity. Then there's dark energy, a force that's making the universe expand faster and faster. Scientists have no idea what it is, but it makes up almost 70% of the entire cosmos. And if that wasn't bizarre enough, let's talk about the Eridanus supervoid, a gigantic empty region of space, nearly 1 billion light-years across, with fewer galaxies than expected. Some theories suggest it could be the result of an ancient collision between universes. Yes, you heard that right, universes. This ties into the multiverse hypothesis, the idea that our universe is just one of many, each with different laws of physics. Could it be that we've found evidence of another universe bumping into ours? The deeper we look into the cosmos, the stranger it gets. And as our technology advances, who knows what other mind-blowing discoveries await us? We've already explored the terrifying depths of black holes and the bizarre anomalies scattered across the cosmos. But what if I told you that the universe is even stranger than we imagined, that time could be manipulated, that white holes, yes, the opposite of black holes, might exist, and that entire galaxies could suddenly disappear without explanation? Buckle up, because things are about to get even weirder. Time warps and spaghettification. The bizarre physics of black holes aren't just objects of destruction, they're gateways to the weirdest physics imaginable. Let's talk about what happens if you fall into one. As you get closer to the event horizon, gravity increases exponentially. Your feet, being closer, would experience more pull than your head, stretching you like spaghetti in a process scientists call spaghettification. Sounds painful? It gets worse. If you somehow survived and crossed the event horizon, you would be cut off from the rest of the universe. Forever. But what if black holes are more than just dead ends? Some physicists believe that black holes might be wormholes, shortcuts through space-time. According to Einstein's equations, if a black hole were connected to a white hole, matter falling in one side could be ejected from the other, potentially in an entirely different part of the universe, or even into another universe. But there's a catch. White holes have never been observed, and if they did exist, they would violate the laws of physics as we understand them. Still, the idea is tantalizing. Could black holes be portals to other dimensions? But black holes don't just consume, they can also give birth to new cosmic structures. Recent research suggests that the Big Bang itself might have been triggered by a massive black hole in another universe. In this scenario, what we call the beginning of our universe could just be the inside of a black hole from a higher dimensional cosmos. It's mind-bending, but mathematically possible. And if that wasn't enough, let's talk about Planck stars, a radical new idea that could change everything we know about black holes. According to quantum gravity theories, when a black hole collapses, instead of forming a singularity, it could shrink to an ultra-dense quantum object, a Planck star, before eventually exploding, releasing all the information it swallowed. If true, this would solve the black hole information paradox and rewrite the fate of black holes as we know them. Galactic ghosts, the mystery of disappearing objects. The universe is vast, but what if entire galaxies could vanish? Astronomers have been puzzled by objects that seem to simply disappear. In 2019, a team of researchers studying the brightest known stars in a distant galaxy found something shocking. One of them was gone. No supernova, no explosion, just vanished. Theories range from an extreme type of black hole swallowing it, whole to the possibility that we witnessed a rare failed supernova, where a star collapses directly into a black hole without any visible explosion. But that's not the only disappearing act in the universe. The vanishing galaxy clusters problem has left scientists scratching their heads. Studies of ancient light, called the cosmic microwave background, suggest there should be more massive clusters of galaxies than we actually see today. Could something unknown be erasing them from existence? One of the most mind-boggling cases is the case of the missing quasars. Quasars are supermassive black holes at the centers of galaxies, shining as some of the brightest objects in the universe. But some have been observed to dim dramatically or disappear entirely in just a few decades, a blink of an eye in cosmic time. Scientists suspect this could mean black holes can turn off and stop feeding, but the exact mechanism remains a mystery. Cosmic glitches, when the universe breaks the rules. Let's go even deeper into the strange and unexplained. Some parts of the universe behave as if reality itself is glitching. Take the cold spot anomaly, a mysterious region of space where the cosmic background radiation is unexpectedly colder than it should be. Some physicists believe this could be evidence of a parallel universe interacting with ours, causing a strange gravitational effect. Then there's the axis of evil, a bizarre alignment in the universe's structure that seems too perfect to be random. Scientists expected the universe to be chaotic and evenly distributed, but some cosmic structures appear aligned in ways that shouldn't be possible. Could this be evidence that something even bigger, something beyond our universe, is influencing the cosmos? One of the most chilling discoveries is the possibility of false vacuums. Our universe exists in what physicists call a metastable state, meaning it's stable for now, but theoretically, a sudden quantum fluctuation could trigger a vacuum decay, essentially erasing everything in an instant. If this happened somewhere in the universe, we wouldn't even see it coming. The effect would travel at the speed of light, destroying everything in its path. It's an unsettling thought, but fortunately, most calculations suggest this won't happen for trillions of years. And then there's the biggest mystery of all: what came before the Big Bang? Some theories suggest our universe is part of an endless cycle, where each universe gives birth to the next in a continuous loop. Others propose that the universe began from a quantum fluctuation, a random energy burst that gave birth to space and time. But without direct evidence, we're left with more questions than answers. The truth is, for all our advancements in astrophysics, the universe still holds secrets beyond imagination. Each new discovery opens up even more questions: black holes, cosmic anomalies, disappearing galaxies, and the nature of time itself. These are just pieces of a much bigger puzzle, one we might never fully solve. Black holes and cosmic anomalies, the universe's greatest mysteries, Part 3. We've ventured deep into the mind-bending depths of black holes, explored cosmic anomalies that defy explanation, and even touched upon the unsettling possibility of reality itself being a glitch in the system. But let's not forget, we're only scratching the surface of a universe that is vast, mysterious, and filled with untold wonders. As we wrap up this exploration of the universe's greatest mysteries, it's time to look at the big questions, the ones that could define the next century of science. The multiverse. Could there be more than one universe? Imagine for a moment that everything you've ever known is just one bubble in a sea of bubbles, universes that are all around us, yet invisible. The idea of a multiverse has long been a subject of debate among scientists and philosophers alike. If true, the multiverse theory would suggest that what we consider the universe is only one of many, each with its own laws of physics, perhaps even its own dimensions of time and space. One version of the multiverse theory, the many worlds interpretation, suggests that every time we make a choice, the universe splits, creating a new reality with every possible outcome. If that's the case, then there could be an infinite number of realities where every possible version of you exists. One where you're a scientist, one where you're a professional athlete, and perhaps one where black holes are the key to intergalactic travel. But how do we even test this theory? The challenge is that if other universes exist, they are out of reach, their effects perhaps only subtly influencing the edges of our own universe. Even so, the idea of a multiverse pushes the boundaries of science, questioning the very nature of existence itself. The future of black holes. Are we close to solving the mystery? As we stand at the edge of this cosmic frontier, one question lingers: what's next for black hole research? Recent advances, like the Event Horizon Telescope, capturing the first-ever image of a black hole, have opened up incredible new avenues of discovery. We now know that black holes are not static objects. They can spin, merge, and even sing through the waves of space-time they generate, as seen in gravitational wave detection. But there's still so much we don't understand. One of the biggest puzzles remaining is the fate of information that falls into black holes. According to quantum mechanics, information can never be lost. But what happens when it enters a black hole? Does it vanish into the singularity, or is it stored somewhere in the event horizon, as some theories suggest? Recent work in quantum gravity might hold the key, pointing toward the possibility of quantum fuzz at the event horizon, where information is preserved in a bizarre form we don't yet understand. In the years to come, space telescopes and advanced observatories will allow us to probe deeper into the heart of black holes, measuring their gravitational fields, their interactions with nearby matter, and perhaps even detecting the faint imprints of ancient universes beyond the event horizon. The mysteries of the cosmos are closer than ever to being unlocked, though many still lie just beyond our grasp. What does it all mean? As we uncover more about black holes, cosmic anomalies, and the fundamental nature of reality, one question becomes ever more pressing. What is the universe really made of? The more we learn, the more we realize that the universe isn't just strange. It's weird beyond comprehension. Dark matter, which makes up the majority of the universe's mass, remains a complete mystery. And dark energy, the force accelerating the universe's expansion, might hold the answers to the ultimate fate of everything we know. And what if we're not alone in all this? Could the universe, its vast expanse and infinite possibilities, be home to other civilizations that have unlocked the mysteries we're still struggling to understand? Could black holes themselves be gateways for extraterrestrial life or even intergalactic travel? The possibilities are endless. One thing is for sure, the universe is still full of secrets, and every new discovery opens up even more mysteries. Are we ready to answer the biggest questions of all? Or will we remain mere travelers on an endless journey into the unknown, seeking answers but never fully understanding the vast cosmos around us? As we conclude this journey through black holes and cosmic anomalies, we must ask ourselves, what's out there waiting to be discovered? What mysteries will the next generation of scientists uncover, and how will they change the way we view the universe? The answers perhaps are already out there, just waiting for us to look a little further, dive a little deeper, and dream a little bigger.